So if I
So
just play
40
with this
would be
data,
my C.
40 would be my C, yeah.
So
If
then it
if
would
I
be
play,
plus or minus because it's C plus MX, right?
so this number is in negative now.
Okay.
You see this, so these numbers in negative.
Okay, minus 0.9.
So it's exactly like the
But
formula for a line. So a line can have a positive, when it goes, like upwards towards the right, then it will be y equals to c plus mx, and
Yeah,
when it slopes downwards, then it
yeah,
would be, then the m would be negative. So y equals to c plus mx would be there, but the m would be negative.
absolutely. Let's do another example. Yes, absolutely correct. You got it. So I have another example to show it to you as well. So similar example that I've taken. So we are doing a regression. Just to tell you again, we are trying to establish whether if there is significant correlation between two variables. So likewise, R value is called coefficient of correlation. Here we are calculating coefficient of determination. Okay. So I pasted the new data here. Okay. So let me go for regression, or I can use this option which I used earlier. So response may we mentioned the sales of jacket, and here it's the temperature. So now the equation that I've got is 5.20 plus 0.392 of temperature. Okay. So, and let's look at the p-value as well. So p-value is 0.010, which is lesser than 0.05. So there is a significant difference. So I have this equation. I click, I copy. Let's try to solve this. Okay. So this equation. So what is my C here? What is my C?
5.20.
Yeah. Okay. So if I want to predict my sales of jacket, what I'm going to do is, so I'm going to do 5.20, start the bracket, 0.3. Okay. If I give, if I want to predict now, because it's a new equation depending upon the data that I've taken, if I mention if the temperature goes to 10, again, if I've done some mistake,
The bracket
before bracket plus.
plus, yeah.
plus, okay, yeah. So 8.2, okay. So if I want to increase it to 30, so remember it is 8.2 here. Okay. If I change, there is paste value. So now if I change it to 30, what do you think? This value should increase or decrease? What do you think?
Decrease. It should decrease.
Increase.
It will increase.
It has increased. It has increased because here in that case, let's do the correlation here. We haven't done the correlation. So we were sort of, so stats, basic stats, correlation. Because there could be a possibility it was a positive correlation. We didn't check that.
Yes, it was a positive.
It is a positive.
You see, it's kind of very
It
high
is
positive.
positive.
That's the reason
Yeah.
it has increased. Yeah. So that's why first look at the correlation and then go for regression. If in correlation you're not satisfied, you see there is no relation, then there is no reason for going for regression test. Okay. So hope you have understood the difference between correlation and regression. Both is to be done when your y is continuous and your x is continuous. Correlation gives me the R value, which is which talks about the relationship between two continuous variables, positive, negative, and linear relation, which is no relation, and it gives me a R value, which is a deciding factor. Regression tells me whether these variables have a significant impact on each other. There the causation picture comes into picture, and it also gives me a regression equation which helps me to predict that if there is a change in my X, what would be a change in my Y also. So that's a kind of regression equation it throws. So you can use this data that I have given it to you, the HT data, the whole time data that you have, and you can play with it. You can use certain data and you can use to understand this in detail. More practice is required to do these tests. So now we have covered correlation, chi-square, one sample T, two sample T, one way ANOVA, one sample Z, Mann-Whitney, Moore's median, test of equal variance, BLR, 2P test. So 2P test is called two proportion test. So let me give you an example when to do this test. Okay. So you have done in the beginning of the project, pre-project, when you started this project, any project that you started, you would have two things at least: defects and opportunities. Yes or no? You would be able to calculate it. Total. Can you do that? Hello?
Yep.
Yes.
It is simple to calculate. Okay, what is my pass percentage? So let's say if I have 100 defects out of 150. Okay, now I have completed the project. It has reduced to 75 and opportunity remains the same. Okay, so I've reduced the defects from 67 to 50. So I had a target of meeting 50%, which I have done. I'm contented with it, but I'm not sure whether I have made a significant improvement or not. I'm not sure about it. So there is a test which helps me to identify whether I have done a significant improvement or not. Okay. So what I'll do is I will do 2P test. So stats, basic stats, 2P. Stats, basic stats, you can see two proportion test. Click on two proportions, click on summarize data, this option. Here you can put a number. So number of trials is the total that we have. So let's take the same example. So 150, 100. So I have number of trials 150. So it says sample 1, sample 2. This is pre, this is post. Okay. I have 100 defects. And in the post project,
75.
75. Okay. Now I want to see whether statistically, significantly, I have made a significant improvement or not. That also something which I can check. And that is to be checked with the help of null hypothesis or alternate hypothesis. Okay. It says P1 proportion where sample 1 is event, P2 proportion where sample 2 is event. Difference P1 and P2, which is proportion 1 and proportion 2. Okay. Here you see, you look at the either one of these P values. Okay. It says 0.003, which means that there is a significant improvement observed between pre and post. So that's what we can do it with the help of two proportion test.
So Simar, what would be the value that we would be looking at?
The probability.
Either of the value?
Yeah, either of the value, either normal or Fisher. So in this case, the Fisher value is very, very closer to conclude whether it's a null or an alternate hypothesis. And the normal approximation says 0.003. Usually 90 to more than 90% case, these values are in the similar direction. Either it shows alternate, either it shows null. And there's a very, very rare scenario wherein, it shows two different values. So in that case, we give a benefit of doubt to the value which has a lesser value. So which says that there is a significant difference between the previous performance and the current performance. or previous performance and new performance. So that's what I can do with the help of two proportion test. So that's what is the role of. So here you don't need any data to look at. I'll just go it once again. You click on the summarize
So
data.
it's more of once we have identified, probably we have handled the current performance, right? And then when we have done all the improvements and implemented the changes, now we have the improved performance where we just compare if the effort that was put in has resulted in a significant improvement or not.
Absolutely. That's absolutely correct. So this
So
test
this
is
must not be, is it a mandatory test, or because we must have agreed upon a target, right? And if I'm able to achieve that, so is this something that we have to do, or it's kind of our choice if we want to do this one?
So it is not a mandatory test that you have to do, but in case if you want to go for it to statistically signify that you made a significant improvement, then you can go for it. Okay, this test is not to be makes the case more stronger, wherein you can conclude with the help of saying that we have not only made an improvement, we have made a significant improvement which would be sustainable for coming months also. Yeah, so this test is not to be done in the analyze phase. This test is to be done at the end of improve phase. Since it's a hypothesis test, that's the reason I've covered it in the analyze phase. And analyze, because we are in the analyze phase right now, we haven't reached the improve state yet. So this test is pertaining to be done once you have deployed all the solutions, you have achieved what you wanted to achieve, and now you want to make your improvement solutions more impactful to the management, to state that I have made a significant improvement as well. Then only you will do this kind of a test. Okay, so we have done the two proportion as well. Sorry. Okay, so now regression test is also done. Now we are left with gauge RNR, the hands-on exercise that we have done. So let's do that, and I will just repeat about the gauge RNR as well, so that we all can relate to what we discussed during last week. So gauge RNR. Gauge RNR is a part of measure phase. It's a kind of test. It's a kind of a test which help us to identify whether there any measurement error observed between two different operators or two different parts which we are measuring. So likewise, when we did the discrete, for discrete, we did the attribute agreement analysis, wherein we have data as pass versus fail. So for example, there were three different operators who have been asked to measure it. So we were calibrating. So I will just show you the slides also so that you can relate to what I'm saying. Can you all see my slides?